Section 4.7, we get to look at some inverses of some of our functions. So we're still messing around with some sine and cosine. We get to talk a little bit about some domain and some range. Why is it that we have to limit our domain and our range when it comes to looking at some inverses? And then ultimately we're going to solve some inverses.
Really noisy.
I'm like, come on, man, you knew we were taking notes.
I think everyone was kind of just hoping.
Just hoping, right? There was a little last-ditch effort.
We lost internet again.
Yeah, exactly. All right. So I got some pictures for you guys. So we're going to talk about what's going on, right? So if I even cross this little guy off, right? And if we look at that graph, we know that it's either sine or cosine. Good job. Awesome. And we know that it's a sine function because, right, it's going through the origin, right? Or it's nice, exactly. Is it a positive or a negative sine function?
Positive.
Positive, right? We're starting to go up, right? Good job. So see, now I can erase that, and we all know that it's a sine. So, way back in the day when you were just wee little math students, we talked about like things that you can do in order to test to see if something is a function. And there was that thing called the vertical line test, right? So anywhere you drew a vertical line, if you only crossed the crossed the function once, you knew that it was a function, right? It was 1-to-1. And then there was this thing called a horizontal line test. Anybody remember what the horizontal line test was used for? See if it has an inverse. Good job, extra credit for you. Yep. So if I do the horizontal line test on this, what happens? Do I cross it more than once?
Yeah.
I do, right? So if we look at the function as a whole, and it keeps repeating and going and going and going, all of those periods, it's not going to have an inverse because it fails that 1-to-1 function on that horizontal line test. But if we go back, we know like when it came to these, like ultimately, you're taking that circle, right, going around the circle, and then that's one cycle. You go around it again, it's another cycle, another cycle, another cycle. So we can really limit this so that way we can find an inverse. So we want to sit there, and when it comes to our sine is x values or y values?
Sine is y.
Sine is y values, right? And we have, you're either going to get positive value. All right, we're going to give it one more shot. How's that? I'll give you that one. All right. I don't even know where I was.
Keep going.
I know. All right, so we want to sit there, and part of it is we know when it comes to our y values, if you think of that first quadrant, our y values are going up, second quadrant they're going down, and then in third they're going down, and in the fourth they're coming back up, right? So we know that our y values are going up and they're coming down and they're repeating. So we just need to find a piece of our graph that shows like our positive values and like our negative values when it comes to our y values, right? So I'm going to kind of look at my graph and I'm like, well, wow, if I need to find like the positive values, well, I should make that a little thicker. Well, we're just going to do it with a highlighter. So I'm looking for where my y values are like positive. And then could I go like where my y values are negative? Right? And if I just look at that little piece of the sine function, would it have an inverse?
No.
Just the little highlighted part?
Yeah.
Yeah, because it passes that horizontal line test. And I include all of the possible values by just looking at that little tiny piece. So when we're talking about inverses of sine and cosine, we're going to limit our domain, right? So our domain is x values or y values?
Domain is x.
Domain is x, right? What's the smallest x value I'm going to look at?
Oh, I'm not good at domain. That one.
That one, right? And what's the largest x value we're going to look at? Pi over 2, right? So if we're talking about the inverse of sine, we're always going to limit our domain to that negative pi over 2 and pi over 2. Oh yeah, so I'll get that right. So if we look at our unit circle on that one, right? So we're going from I can't add on top of, right? So we're going from pi over 2 to negative pi. Oh, little delay in there. So these are the values that I want to look at. So if I look at my little fancy unit circle, and I know it's kind of small up here, but we'll get, yeah, we're just going to think visually, right? So if I'm going from 0 to pi over 2, where am I going from? I'm going from 0, where's pi over 2 going to be? 90 degrees, right? Yep, so I'm looking at these values, right? And I'll blow it up a little bit. Where's negative pi going to be? Yeah. So if I'm going negative, I'm going to go down, right? I'm going to go clockwise. And pi over 2 is just going to get me to the 90 degrees, right? So I'm talking about these guys down here, right? So I'm talking about y values from like -1 to 1, right? And that's going to include all of my y values, because if I look at the other side of my circle, like these y values are the same thing on this side, right? So I don't need to look at all of my values on my circle, because they're just going to repeat every half. Right? So that's our little piece that we're looking at. Right. Yep. And then I just made a little table for you guys, right? Right. And you guys, well, it's all on your unit circle, right? So if we start at 0, right? If I'm starting at 0, what's my sine value going to be? 0, right? Pi over 6 is going to be, yep, at 1/2, right? Pi over 4 is going to be what? √2/2. Yeah. Pi over 3? Square root of 3 over 2, right? Oh, we just did pi, yep. And then, woo! Pi over 2 is going to be 1, right? So when I go to do my negatives, right, where's negative pi over 6 going to be?
-1/2.
Yeah, it's just going to be right here, right? -1/2. Where's negative pi over 4 going to be?
-√2/2.
Yeah, look at you. Where's negative pi over 3 going to be?
-√3/2.
Negative, yep. And where's negative pi over 2 going to be?
-1.
-1, right?
We're so good with this.
Absolutely you are, right? So when it comes to our sine values, and when we get to looking at these inverses, these are the only values that we're going to be looking at, right? That's it, right? So exact values for sine of theta, right? And then remember, we limited our domain, and we said we were only going from negative pi over 2 to pi over 2, right? So we're really looking at like that quadrant 1 and quadrant 4.
Your phone's ringing.
My phone's ringing. Talks amongst yourselves, right? All right. So now we're going to find some inverses. All right. So you guys remember finding inverses before? It's got that little -1 on there. All right. You guys are going to be blown away by this, all right? So finding inverses. So I don't know. Let's find the inverse, right? Oops, that's kind of a little sloppy, but you guys are good with my handwriting. Square root of 2 over 2, right? And we know that the inverse, right, like sine to the -1 of x or whatever, that's inverse. That's not 1 over sine of x, right? That's not saying that you're finding the reciprocal. Okay. That would be, this would be if you had sine of x and the whole entire thing was to the -1, right? You guys get on the difference between like reciprocals or inverses? Did you guys get with that one? Alrighty. Maybe. Right. So when it comes to this, if we're finding the sine or that inverse, we're trying to find that theta. We're trying to find what that value is for that radian. So we're going to sit there and start off by saying like theta equals sine inverse of square root of 2 over 2. Because that's what we're trying to find. We're trying to find what theta is. So in order to do that, I need to figure out how to get rid of that inverse. So anytime we multiply any function by its inverse, it goes away. It becomes 1, right? So I'm going to multiply both sides by sine. So now I have sine of theta equals sine times the sine inverse of the square root of 2 over 2. Anytime we plug an inverse in for a function, it just becomes 1. So my sine and my sine inverse are going to cancel each other out. So now I have sine theta equals the square root of 2 over 2. When does sine equal square root of 2 over 2? Somewhere on the unit circle, right? So, yep, 2 options, right? You can look at your unit circle, and we're looking for that y value, that's square root of 2 over 2. And we're only looking in that first and fourth, right? So, square root of 2 over 2 is pi over 4, right? Or if you sat there and were bored and you made the little table, right? Square root of 2 over 2, pi over 4. So good. Sorry, whoops. So we're going to get pi over 4. What if I wanted you guys to find, let's say, this inverse, sine inverse of negative 1/2? So we're looking for theta of sine inverse of negative 1/2. I want to get rid of my inverse. So what am I going to do to both sides? Multiply it by sine. Yeah. So sine theta, sine times sine inverse of negative 1/2 equals negative 1/2. So where do we think we're going to get negative 1/2 at? If we look at our unit circle, right, we found our negative half, and it's at that like 11 pi over 6, but we want to keep it as positives and negative 1/2, pi over 1/2, so this would be the same thing as negative pi over 6. Right? Or we could go off our little table. Where's negative half? Negative pi over 6. Not two shabs.
Is that it?
We're just, yeah, same thing, but we're going to talk about cosine real quick.
Oh, okay.
Same thing, but yep. So if I gave you guys this little, whoops, because we don't know what it is yet, right? If I gave you this, is this going to be sine or cosine? Cosine. Is it going to be positive or negative? Positive, because I started at the positive 1, right? Look at you guys. Can't fool you, right? So again, same thing that we were talking about before. It's going to fail the horizontal line test if we keep all of it. So we need to find a piece that where we have all of our positive and negative values. So, like, and you can kind of pick it easy anywhere. We just try to find the easy spot, right? So I think we're going to go from, oops, nope. From here to here, right? That includes all my positives and negatives. So I'm going to start at 0 and go all the way to pi. So my domain is going to go from 0 to pi. And that's that little piece we're going to look at. Make sense? Kind of a little bit of a shift just on where it's at. And then we're going to look at our values. So if we look at our little unit circle, we're going from 0 to pi. Where's pi going to be? Where's pi on our unit circle? 180, right? So I'm looking at all of my x values from 0 all the way to pi. And I'm getting my positive x values and I'm getting my negative x values. So I'm just going to look at those top two quadrants, quadrant 1 and quadrant 2. Right? So we're just looking at that little piece. Ooh, we'll skip to this one, right? So if I wanted to turn it into a table, when sine is 0, or when theta is 0, my x value is going to be 1, right? Pi over 6 is going to give me a cosine value of square root of 3 over 2. And then we're just going to keep going all the way around. Makes sense? All right, ready to try one? Find some inverses of these guys. So find the inverse. Not the universe, just the inverse. I don't know. Oh, yeah, I already told you. 0 to pi, right? Let's find cosine inverse of negative square root of 3 over 2. So what are we trying to find? We're trying to find definition of life, little theta, of cosine negative 1, oops, oh boy, negative square root of 3 over 2, right? How am I going to get rid of the inverse? Multiply both sides by cosine. So cosine theta. So you find where cosine is negative square root of 3 over 2. Anybody find when the cosine was negative square root of 3 over 2? 5 pi over 6. Woo! 5 pi over 6. Well, whoops. Let me rewrite that. I lied. That's written improperly. Negative square root of 3 over 2. So then our theta is 5 pi over 6. Calculators. So find values using a calculator. Sorry. So like they want you to find the sine inverse of 0.25, right? And your fancy dancy little calculators. So the inverse is the second sign button. I think you guys are good with that part. But we have to talk about our mode, the mode that we're in when it comes to our calculator. I'm going to squeeze back for just a second. When we did all of these, and we're looking for those thetas, right? That 5 pi over 6, or even all of these. These are all in radians, right? This is that radian measure of our circle. So when we're talking about radians, we need to make sure that our calculator is in radian modes. If we were talking about degrees, we need to make sure that our calculator is in degree modes. And these ones are all radians, right? So we're talking about radians. So this is where they just want you guys messing around with your calculator. So on this one, we need to make sure that we are in radian mode. I should do this both ways. So if I put it in, make sure I'm in radian mode. Bless you, bless you. Everybody know how to change them? Oh, we should look at that on Desmos too. Bless you, bless you. Second sine of 0.25. You get approximately 0.2527. If I was in degree mode, which would be the wrong mode,